Introduction to Docker for developers. Picture this. You just finished building an awesome web application on your local machine. Everything works perfectly. You're ready to deploy, but then your teammate tries to run it and gets a dozen dependency errors. Sound familiar? That's where Docker comes in to save the day. Docker has revolutionized how we develop, ship, and run applications. It's like having a magic box that packages your entire application with everything it needs to run: code, runtime, system tools, libraries, and settings. No more "it works on my machine" excuses. What exactly is Docker? Think of Docker as a lightweight virtualization platform. While traditional virtual machines virtualize entire operating systems, Docker containers share the host OS kernel but isolate the application processes. This makes containers much faster to start and more resource efficient than VMs. At its core, Docker uses three main components. Images, read-only templates that contain your application and its dependencies. Containers, running instances of Docker images. Dockerfile, text files with instructions to build Docker images. Docker Hub, cloud-based registry for sharing container images. Your first Docker container. Let's jump right into creating your first Docker container. We'll start with a simple Node.js application to demonstrate the basics. Simple Express.js server with two endpoints. Root endpoint that returns a JSON response with message, environment, and timestamp, and a health check endpoint that returns server status. The server listens on configurable port with environment variable support. Now here's where the magic happens. Instead of asking your teammates to install Node.js, npm, and figure out which version you're using, we'll create a Docker file. Docker file that sets up Node.js 18 Alpine environment, creates working directory, copies package files, installs production dependencies, copies app code, creates non-root user for security, exposes port 3000, and defines startup command. Follows security best practices by running as non-root user. Quote, "The beauty of Docker isn't just in solving dependency issues. It's about creating reproducible environments that work the same way whether you're developing locally, running tests in CI, or deploying to production." Personal experience. Building and running your container. With your Docker file ready, building and running your container is straightforward. Here are the essential Docker commands every developer should know. Essential Docker commands covering the complete container lifecycle. Building images with tags, running containers in detached mode with port mapping and environment variables, viewing running containers, checking logs, executing interactive commands inside containers, and properly stopping and removing containers. Multi-container applications with Docker Compose. Real applications rarely exist in isolation. You probably need a database, maybe Redis for caching, and perhaps a reverse proxy. Docker Compose lets you define and run multi-container applications with ease. Docker Compose configuration defining a complete application stack with web service, Node.js app, PostgreSQL database, Redis cache, and Jinx reverse proxy. Includes service dependencies, environment variables, port mappings, persistent volumes for data storage, and inter-service communication setup. With this Compose file, you can spin up your entire application stack with just one command. Docker Compose upd. Your app, database, cache, and web server all start together and can communicate with each other seamlessly. Docker best practices for developers. After working with Docker in production for several years, I've learned some hard lessons. Here are the practices that'll save you headaches down the road. Here are the practices that'll save you headaches down the road. Use multi-stage builds to keep your images lean and secure. Don't run containers as root. Create dedicated users for better security. Leverage Docker Ignore to exclude unnecessary files from your build context. Use specific image tags instead of latest to ensure reproducible builds. Implement proper health checks for your containers. Use secrets management instead of environment variables for sensitive data. Here's an example of a production-ready Docker file that follows these best practices. Production-ready multi-stage Docker file for Python Flask application. Uses builder stage for dependencies, creates non-root user for security, implements health checks, copies files with proper ownership, cleans up package caches, and uses Unicorn for production server. Demonstrates security best practices and image optimization techniques. Debugging Docker issues. Docker containers can sometimes feel like black boxes when things go wrong. Here's how I approach debugging container issues. Docker Debugging Toolkit, including interactive container access, detailed container inspection, resource monitoring, file system change tracking, container export for analysis, Docker daemon log checking, and cleanup commands for maintaining system health. One thing that took me way too long to learn is the importance of proper logging. Always configure your applications to log to stout/stare so Docker can capture and manage your logs properly. Quote, don't try to debug a container by sshing into it. Containers should be treated as immutable infrastructure. If something's wrong, fix the image and redeploy rather than patching a running container. DevOps best practice. Performance optimization tips. Docker containers can be incredibly efficient, but there are several optimization techniques that make a huge difference in real-world applications. Docker containers can be incredibly efficient, but there are several optimization techniques that make a huge difference. Use Alpine Linux-based images to minimize size and attack surface. Implement proper layer caching by ordering Dockerfile instructions strategically. Use that Docker Ignore to prevent unnecessary files from bloating your build context. Configure appropriate resource limits to prevent containers from consuming excessive resources. Implement container orchestration with proper scaling policies. Here's a practical example of optimizing a typical web application container. Before and after Docker optimization example, showing transformation from inefficient single-stage build to optimized multi-stage build. Optimized version uses Alpine Linux, separates dependency installation, implements proper caching, creates non-root user, adds health checks, and uses more efficient layer ordering for better build performance. The key insight here is that Docker builds layers incrementally. By copying package.json first and running npm install before copying your source code, you ensure that dependency installation only happens when your dependencies change, not every time you modify your application code. Integration with development workflow. Docker really shines when it becomes part of your development workflow. Here's how I integrate Docker into daily development. Development workflow integration showing Docker Compose override file for development-specific configuration with volume mounting for live code updates, development environment variables, and debug settings. Includes makefile with common development tasks for easy command execution and project management. This setup gives you the best of both worlds, consistent environments across your team, while maintaining the fast feedback loops you need during development. File changes are reflected immediately thanks to volume mounting, but the entire stack runs in containers. Docker has transformed how we think about application deployment and development environments. What used to require complex setup documentation and hours of environment configuration now takes minutes. The consistency Docker provides between development, testing, and production environments eliminates entire classes of bugs. Whether you're building microservices, monoliths, or anything in between, Docker provides the foundation for modern application development. Start small with a simple Docker file, then gradually adopt more advanced patterns like multi-stage builds and orchestration as your needs grow. The learning curve might seem steep at first, but once Docker clicks, you'll wonder how you ever developed applications without it. Your future self and your teammates will thank you for making the investment in learning this essential tool. Enjoyed this video? Hit the like button and subscribe to stay tuned for more.